Welcome, ladies and gentlemen, to our second video here for our Unit 3 test review. We're going to do a hypothesis test, and this one is going to deal with a small sample size because it says right from the very start, a survey of 15 large U.S. cities finds that the average commute time one way is 25.4 minutes. So this small sample size of under 30 pieces of data is going to tell us we're going to probably use the t-test. Or a t-chart because we have less than 30 pieces of data. And this is going to be our mu here because this is what we're going to be checking to see if this is valid, if mu is the correct mu, because our null hypothesis is going to say that our mu is equal to 25.4. Our alternative is going to say something different than this, but let's take a look at what we have elsewhere in the problem. By surveying a sample of 25 commuters, the city commissioner feels or finds that the mean is 22.1 minutes with a standard deviation of 5.3 minutes. With an alpha of 5%, can the commissioner conclude that it will take less time? You know, he's trying to say that it takes less time to commute in a city. So his alternative hypothesis is going to be that mu is going to be less than, I know I just wrote an equal sign by accident there, less than 25.4. These always match. This is the null that, nope, still commute time is 25.4, but he's saying, no, it's probably less than. I mean, his data shows that the average is less, and the standard deviation does kind of put it above here if I added the 5.3 to the 22.1. So now what I have to do is figure out what my critical value is. How many standard deviations below the norm must this group be before I can say that this is going to be, basically enough to change my idea about the mu? Well, my critical value is going to be based on degrees of freedom. And my degrees of freedom in this case is my 25 commuters right there, and my 25 commuters is also under 30, so there's another value that talks about, t being the chart to use here. This would have really been a tricky problem if we had basically said this was over 30. You could then make a case to say that you would use the z instead of the t here, but my degrees of freedom in this case is going to be 24. Because degrees of freedom is based on n-1, and therefore we're going to get our critical value from that table at 24 degrees of freedom. We're going to look up left tail, or one tail, on that column. So we're going to go to that row that says left tail with an alpha of 5%. So left tail alpha of 0.05 or 5%. At 24 degrees of freedom, we're going to be at negative 1.711. Now what's important about the critical value here, it has to be negative because we are on a left tail. If you put down positive 1.711, you'll note that when we do the test and show that in our picture, we're going to have a serious problem. So let me move down into the next part of this where it says run the test and show all the work. And in fact, I will run the test up here so you can see the entire second half of the problem here. Now let's first of all put back up on this screen, since we scrolled down, the critical value, which we said was negative 1.711. We're going to see if our test value is below 1 711 thousandths. So we take our formula, which is our going to be our x bar, and we subtract it from our mu and divide it by the standard deviation divided by the square root of the sample size, in this case 25. So that first survey of the 15 large cities that never got used here, that was just basically part of where we got the 25.4. So if you had the 15 used in any part of this problem, you made a mistake there. If you do this correctly, you'll get an answer of negative 3.11, which is significantly lower than our critical value. So let's put everything up here on the normal curve. 0 to show us the center here, which is 0 standard deviations away from the norm. Our critical value, our CV, is at negative 1.711. Everything to the left is shaded, and we're going to put our flag at negative 3.11, which is our test value, and our test value is in the critical region, so we are going to reject the null hypothesis and we will say that we will reject the null hypothesis because negative 3.11 or 3 and 11/100ths is less than 1 and 711 thousandths. You could have also said that you could flip this around by saying, 1.711 is greater than 3.11. And that, my friends, is our hypothesis test number 1.